Hello, game developers. Welcome back to Temp Game Dev. Today, we're diving into the development of our new game, Waterworld Jumper. In this first devlog episode, we'll be creating the initial environment by replacing the base plate with a beautiful island and adding rotating logs as the first obstacle. Let's get started. To begin, we want to replace the default base plate with an island. In the Terrain Editor window, click on the Edit tab and then select the Draw button. For the brush and material settings, stick with the default options except for base size, set it to 40, and material, set it to sand. Now, click near the spawn location in the viewport and you'll see a sphere of sand material appear. To shape the island, switch to the Flatten mode in the Terrain Editor. Adjust the brush settings by setting base size to 20 and enabling Fix Plane. Set plane position to 0. Then click on the Sculpt button. Keep material as sand and use your mouse to click and drag around the island's edges and below the waterline for a natural look. Next up, let's create the water around our island. Click on the Fill button in the Terrain Editor. In Selection Settings, set position to 0, -15, 0, and size to 2048, 20, 2048. In Material Settings, set Material Mode to replace, Source Material to Air, and Target Material to Water. Click Apply and voila! Water generates around the island. To add some greenery, set base size to 3 and material to grass in the brush and material settings. Now, your island has a nice touch of grass to enhance the environment. Now, let's introduce our first obstacle, rotating logs. Add a part. Create a part script with the following code. Local turning speed equals 2. While true, do. Script parent.cframe equals script parent.cframe * cframe. Angles math.rad turning speed 0, 0. Weight 0.01. Here's a simple Lua script for our rotating log obstacle. The variable turning speed controls how fast our log will rotate. In this example, it's set to 2. You can tweak this value to get the desired rotation speed. I did change the assembly angular velocity from the part's properties to a script that is attached to the part. Let's break down the modification. Local log equals script parent. This line declares a local variable named log and assigns it the value of script parent. In Roblox scripting, script parent refers to the object, in this case, the part that the script is directly placed within. Log.assemblyAngularVelocity equals vector3.new2, 0, 0. This line sets the assembly angular velocity property of the part, log, to a vector 3 representing angular velocity. Angular velocity describes how fast an object is rotating. In this case, the part will rotate around its x-axis at a speed of 2 radians per second. The change essentially involves moving the configuration of the angular velocity from the part's properties directly to a script. This can be advantageous in terms of organization and flexibility. With the configuration in a script, you can easily modify and control the behavior of the part dynamically through scripting. It also allows for more dynamic and complex logic if needed in the future. Duplicate the part, Ctrl+D, or right-click and select Duplicate and add as many as needed for your game. Experiment with different sizes to create engaging obstacles. With the first part of our course finished, stay tuned for the next episode. We'll be creating a new island with fresh obstacles to keep the excitement going in Waterworld Jumper. Don't forget to like, subscribe, and hit that notification bell to stay updated with our game development journey. Happy coding and see you in the next devlog.